Hi, this is Mr. Manley, and I'm going to make a video here just doing an introduction to linear programming. So this is just an introduction. I'm not going to go through the whole process. Linear programming was a concept that was developed by a mathematician, George Dantzig, during World War II. And when you see it, you think, well, why didn't anybody think about this before? Because it really is an elegantly simple solution to the need to optimize the allocation of resources, which is what it was developed for during World War II. They had the Pacific theater and they had the European theater of operations, and they had to figure out how they were going to move around personnel and move around supplies and equipment and stores. And George Dantzig determined this most efficient way to find the optimum allocation of resources. I'm going to use an example here just to get started to see how this works. Not from start to finish, but just to get kind of the basic idea. In this case, in this example, I have a manufacturer who wants to maximize the combined profit for two types of boxed chocolates. A box of chocolate covered creams, which yields a profit of $1.50 per box. So let's put that down. $1.50 profit for these cream chocolates, and a box of chocolate covered nuts. So the profit for the nut style chocolate is $2 per box. And market tests and available resources, so there's that word resources, allocation of resources, indicate the following constraints. And this is going to be an important word to us, constraints. The combined production level must not exceed 1,200 boxes per month. So we've got 1,200 box max, and that's combined between the cream chocolates and the nut chocolates. The demand for the chocolate covered nut chocolates is no more than half the demand that of the chocolate covered creams. So that's kind of a mouthful there. So let's see. I will say that nuts no more than half creams. And then the production level for the chocolate covered creams must be less than or equal to 600 boxes, plus 3 times the production level for the chocolate covered nuts. So again, that's a mouthful there. So it must be, what is that? It was creams less than or equal to, less than or equal to 600 plus 3 times the production level plus 3 times the nuts. Okay? So these are all our constraints. So this would be interesting without even knowing what linear programming is. This would be interesting to see if you could figure out how many boxes of each type should be produced in order to maximize profit. And we have a key number here is this one, right? We have the 1,200 box max. That's the most that we're going to be able to produce, whatever it is, per month. Yeah, that's the most that we're going to be able to produce per month. So you could really begin there, right? and use that in combination with these other two constraints. These are called constraints. That's an important word. And what the constraints are actually going to be, they're going to be inequalities. That's what the constraints will be. They will be inequalities based upon this wording here that tells us what our limits are. So what I'm looking for in order to do a linear program is I'm looking for constraints, and then I'm also looking for something called an objective function. Now again, remember, you could figure this out at this point. You could figure out how many boxes of each you would want to make in order to maximize profit. It might take a little bit of guessing and checking, but you could do it. You got this 1,200 box max, and you could, again, guess and check your way to at least get some ideas about what some possible production schedules are. But what linear programming says is we're going to do this with a method that requires an objective function, and it requires constraints. The objective function is typically in the type of problems that we're dealing with in a pre-calculus class, or perhaps an Algebra 2 class. The type of problems that we're dealing with there, the objective function is probably going to be, not guaranteed, but a good idea is to look for a profit. That the objective function is going to be a profit function. A variable that we would use for that then, of course, would be p. So we would say in this case, p is equal to what? The profit in this case is going to be equal to 1.5. So I'm going to make $1.5 per each of the chocolate covered creams, each of those boxes, plus I'm going to make $2 off of each chocolate covered nut box. And that's the profit function. And then if I went in, again, if I did nothing else at this point, as far as linear programming goes, I've got this 1,200 number here, that 1,200 number here, and I could try some different numbers for C and N and look at some different profits that I could possibly get. That'd be a good exercise to do if we were in a class. Just say, everybody try and maximize profit, and people would try some different things and see if they could do that without even doing linear programming. So that's the objective function. The next thing that we are going to want to look at are the constraints. And the constraints are these inequalities. So one of these inequalities in this case is, of course, n plus c. And n and c, we're saying that's the number of boxes of nut chocolates and the number of boxes of cream chocolates. N plus c has got to be less than or equal to 1,200. So that's one of our constraints. It's an inequality that comes from these statements about this situation. And then we look at the next one. The nuts are no more than 1/2 the creams. The number of boxes of nuts is no more than 1/2 the creams. So it's got to be less than or equal to, right? The number of boxes of nut-covered chocolates has got to be less than or equal to, it's got to be less than or equal to half of the creams. So, all right, and then to finish out this inequality, we need the 1/2, right? So the number of nuts is less than or equal to 1/2 of the creams. That knocks out that second sentence there. And then the last one is that the creams must be less than or equal to, the production level for chocolate creams must be less than or equal to 600 boxes plus 3 times the production level for the nuts. So C must be less than or equal to 600 plus 3n. All right. Now, if you've done anything with systems of inequalities, you would be seeing that here, right? You'd be seeing a system of inequalities with 3 inequalities. I want to, now just generally speaking, I'm not going to actually do this. I'm going to go to the next page and say, look, I have 3 inequalities. Now, let's just say that those inequalities came in and graphed like this. Like, say I had one come down like that, and one come in like that, and one go across like that. And then I say I solve that system of inequalities, and I find that the solution to the system of inequalities is in here. And that's my solution set. Something that I teach when I teach the system of inequalities at the pre-calculus level, at least, is to look for the corner points. So these are the corner points here. And that is a term, that is actually a linear programming term, corner point. What linear programming says is that the optimal circumstance, the optimal combination, in this case to produce the highest profit, is going to be at one of these corner points. We don't for certain know which one, and we have to check them. So I would find that corner point, and I'd find that corner point. I'd label it myself. I'd label it A, B, and I'd label this corner point C. That's corner point D. But of course, it's not going to be E, but I'll label that corner point E. And I'm going to check each of these corner points and see which one, because each of these will have coordinates, right, that we will be able to find. We'll be able to find the XY coordinates, or in this case, the NC, because we're going to have nuts on one axis and C for the creams on the other axis, right? So we'll be able to find the coordinates for each of these points, and we will check these coordinates. We will plug them in back here. We will plug them into the profit equation and see which one yields the maximum profit. And that's how linear programming works. We have the objective function. We use the constraints to find inequalities. We graph the system of inequalities, and then we look for the corner points, and we plug the corner points in to the profit equation and see which one maximizes the profit. And this is a process that we can go through in order to optimize some situation. It would also be something that we could go through in order to I guess minimize a situation as well, to find what's the lowest possible thing. Like, for instance, for cost, if I want to minimize cost instead of maximize profit, this would be a situation that linear programming could deal with as well. In a subsequent video, I'll go ahead and look at a specific example. Maybe I'll just finish this one and look at the way it works out numerically. But I just want to do it. This is just an introduction to linear programming to get familiar with the concept and have some understanding of what's happening with the concept of linear programming before actually doing one.